Hello everyone, and welcome back to the Everbloom Devlog series. We're so happy to see you all here. Before we get into the development part of the video, some things have happened since our last upload, and we'd like to address some of that first. If you'd like, feel free to skip to this timestamp on screen. No hard feelings. Firstly, from everyone on the Everbloom team, thank you all so much for the explosion in popularity this project has garnered since the last upload. When we initially released episode 1, we knew it would do slightly better as that video had more things to show in relation to the game. However, what we were not expecting was for it to blow up to the degree that it did. We originally would have been more than satisfied with just 200 views, but you all well exceeded our expectations, as you could probably tell by our last community post. We can only hope to meet your expectations. Please bear in mind that we are a very small team of inexperienced game devs who just want to make a fun, cute little video game that we ourselves would enjoy playing. While we may come across as very formal in these videos, we actually have zero backing or obligations to any big studios. We are solely relying on our free time and passion to develop this game, so your interest is much appreciated. Sincerely, thank you. We also want to give specific thanks to those who left comments on both of our videos. The support has been unbelievable, and we're so happy that you all are as excited for Everbloom as we are, even with what little we've shown thus far. Of course, not only did you all leave incredibly nice and supportive comments, but also very valid criticisms and suggestions for how to improve Everbloom. This is exactly what this series is all about. We really want community interaction to be a central focus on how we proceed in development, so making a devlog seemed like a no-brainer for a wide range of instant player feedback. Speaking of which, let's answer a couple of recurring questions and criticisms we got in the last video. How many people are working on the game? We have 3 active developers working on the gameplay itself, of which there are 2 programmers and 1 artist. We also have 3 other members who handle the game design, social media management, and story writing. What software do you use? For most of the visuals, our artist uses Photoshop. When they need to make tiles repeatable or do animation work, they use Asprite. Thank you Chaotic Mew for encouraging us to use Asprite's tile feature. It has been quite useful. The programmers mostly stick to Visual Studio and Unity. What's the animated character from? We were actually a little surprised to see a few comments related to this. All it is a quick placeholder animation our artist made. If you'd like to use it for your own project, head to the link in the description to download it for free. It's our little thank you for all your amazing support. Do you need a music composer? As it stands right now, this is purely a passion project. We currently are financially incapable of hiring talent for music or any other aspect of the game. Thank you to all the talented individuals who reach out to us offering their service. It's something we'd like to consider in the future, so stay up to date on our Twitter or YouTube for if we post any updates. Why was there such a struggle when dealing with Unity's pivot points? We touched on this briefly in the last devlog, but the biggest issue was that we had initially planned on mapping out the entire game within Tiled Map Editor. After looking more into this, we realized that it isn't feasible due to the way Tiled handles pivots. As a sprite gets placed, Tiled automatically assigns an unchangeable pivot point to the bottom left corner of it. This makes it difficult to change anything related to its layering relative to the player. Will you be making any guides and tips on game development? Yes, absolutely. In between devlog uploads, and when we get the chance, we'll upload videos dedicated to topics such as specific programming techniques or art fundamentals. After months of development, we feel that it's finally time to start making some actual game-like features. This month's video will primarily focus on the most basic version of farming. There were many ways to start creating the system for farming, but we still had some unanswered visual questions. Questions such as, are we going to use the same sprites in the main inventory as what the player holds in their hands, similar to Stardew Valley or Minecraft, or do we want to have unique sprites dedicated to each? In our case, after experimenting with a lot of different styles and aesthetics, we opted to go with the latter. With the way we are handling animation work in Everbloom, creating dedicated sprites is the more appealing option. After a bit of time, we have the completed concepts for the HUD and item sprites. Implementing this HUD is something we'd like to have done by the next devlog if possible. In the meantime, we're receptive to any and all player feedback regarding the readability and aesthetic choices we've made. To pick up from our last devlog, after making a workable level, we got to work on implementing the most basic farming mechanics. Right now, we're missing all the most fundamental assets for farming. Things such as farmable dirt, tilled dry dirt, and tilled wet dirt. This took a stupid amount of time because our artist was experimenting with making the farmland dynamic in order to remove the tiled look pixel art games tend to have. Ultimately, it would simply take too much development time to make something like that a reality. It isn't something that's completely off the table, however, there are other more important gameplay tasks we would like to prioritize first. Now that we have all the necessary assets, we can finally start building our garden and having a workable area to grow plants. We need some way of allowing the player to till the ground. We plan on only allowing the player to till dirt tiles as that's what makes the most sense to us. Of course, we need a dedicated tool to do this, so creating a garden hoe is in order. Functionally, this item works by adding a tilled tile to the ground that you highlight. Using a roll tile created by the earlier tile set, we now have automatic joining of tiles via Unity. Finally, using a previously created system for placing items, we can place a crop with a custom grow script and bam, we have crops in the game. After creating a tilling animation, we're starting to really look like we're putting in a hard day's work. Crops are looking a little thirsty though. We need a script to handle watering the plants. Let's program that real quick, this shouldn't take long. Whew, alright, got that all written up. Let's see how that looks. Okay, looking good so far. Oh. Wacky. Right, so we need a way to fix that. We could try to make a unique case for every single possible tile combination, but then, well, our tile sets would end up looking like this. There's actually a much simpler solution to this. We can use something that's called a stencil buffer. A stencil buffer has an 8-bit integer value for every pixel on the screen, with the default value for each being 0. When rendering the dirt tiles, for each pixel rendered, we can set its corresponding value in the stencil buffer to 1. Then, when we render the wet tiles, we can check before rendering each pixel whether its stencil buffer value is 1, and if it is, then we render it to the screen. Currently, we have no animation for watering the ground yet, so our little cloud guy instantaneously evaporates before recondensing once he finishes watering a tile. As you heard in the opening sequence, we have sound now. Our art guy is super cool and talented and attractive, so they make some custom ambient noises to play in the background. Right now, the ambience is a little empty, so we plan on eventually adding some bird noises and other random sound effects. However, before we get to that, we believe that it would be nice to have a script dedicated to playing sounds at random intervals, rather than having the sound always play at predetermined points. This will in turn sound more natural and immersive. Because our programmers are equally as cool, talented, and attractive, they wrote up a script to handle something like that. We don't have this fully implemented quite yet, however, here's a preview of what this system might sound like after some tinkering. Let's talk game architecture. As we mentioned previously, we are a small team with little to no experience making video games. Due to this, we don't have much experience with game architecture and have been learning as we go. One thing we worked on this month was cleaning up how we handle scene loading and initialization. Previously, our methods were tangled and disjointed, with multiple scripts handling initialization in different ways and at different points in the scene lifecycle. In our case, Awake handles dependency injection, and Start handles game loading and saving. This requires us to have a third event, load save, which is responsible for telling scripts the save file has been loaded. Ideally, a single script would be responsible for loading the game, initializing a scene, and managing the scene lifecycle. Currently, this logic is separated into multiple scripts, which is confusing and overly complex. To fix this, we'll start by creating a new script, which we'll call the Game Manager. Since this script exists outside a scene, we'll create a new global object and move other managers required for the game to function there. Finally, we'll make this object immortal by adding a Don't Destroy on Load script to it. Now that we have a game manager that exists outside the scene, we can implement the game loading and scene initialization logic. To do this, a function runSceneStartup was created to manage the startup of the game and the scene. It has a few different jobs. First, it injects dependencies into scripts that implement the iDependent interface via the dependency injector script. Second, if the game is not already loaded, it loads the save file and its data via the Save Manager script. In addition to this, the configuration scene is loaded. A better name for the configuration scene would be UI scene, as it contains the UI and is responsible for the UI lifecycle. Third and finally, it runs the load savable event to load data into scripts that implement the iSavable interface via the Save Manager script. And That's all for the run scene startup method. From here, it will be called by other methods responsible for changing scenes or starting the game. Using this improved design, we can get a much simpler flow. Dependency injection and save load happens before start, so we can use start normally. There's so much more we wanted to show off this month. Unfortunately, there were quite a few back-end issues that needed to be sorted out, and we didn't have enough time to finish everything we had planned. But don't worry, that'll just make the next Devlog episode all the more exciting. We are super eager to show off some really cool features we have planned, and we hope you stick around to find out what they are. If you like how the project is progressing so far, then please leave a like and subscribe, and see you in 30 days.